Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the Toshiba T1000 laptop. And I'll always say I have actually made a little bit of progress off camera, so to speak, and I'll just show you here. We go up onto my display monitor. Now forgive the fact it's a bit flickery and a bit crap because this monitor is literally on its last legs, and I'm sure as soon as I reset the computer we won't get a lock picture. It's took me ages to get this picture to actually sync and lock, but if you can see there, we have DigDug running, and that means I've actually got the disk drive working. Well, I don't know if there was anything wrong with the disk drive or where it's just set up a really weird way, because basically it seems to work as drive B. I'm not sure it's something to do with this switch or whatever, but I tried a disk with some software on it, and I tried it as drive B, and it actually did load. Like I said, that allowed me to load DigDug up here, and it's perfectly playable. Like I said, it's in like a grayscale. I'm sure there should be some way of getting, well, it should be able to output colour through its TTL RGB output, CJ colour, but at the moment, like I said, we've just got a composite output coming out of it, but it is only mono. But at least it shows us we can actually play the, as you can see, we can actually play the game. And this is exactly what I want this computer for, you know, really basic old computer games like this. I'm not brilliant at them. I do enjoy playing them. As you can see, I'm not brilliant at them. Anyway, yeah, so we've proved that basically the computer does work. I'll just stop that now. Escape. In fact, let's try something. Let's what I haven't done yet is got it to boot another operating system. That's just loading off the MS-DOS 2.11 that's actually built into ROM. I've took an old Amiga disk there, and I've just copied MS-DOS I think 4.1 onto that disk, so I'm going to just see if we can get that to boot. I'm going to put that in the computer. I'm going to have to take the disk out that I've just loaded DigDug off. Put that in the computer. We'll try Control-Alt-Delete, and we'll just see if we can get it to boot off that MS-DOS there. That's function. Control-Alt and Delete. Well, it doesn't seem to be resetting the computer, but sometimes. Let's just try a good old-fashioned switch off and switch back on, shall we? We'll switch off, switch back on. Now we will lose the display, but what I should be able to do, if I think I've pressed function and end, I think it's function. There we go. But this is the problem we've got. Can you see how that's flickering away there? Now it's not. I have just put MS-DOS 4.01 on that disk, and as you can see, it doesn't want to non-system disk error. And I got that when I tried. I think it's MS-DOS. It's what's used on Windows 98, MS-DOS 7 on this disk, and it won't have that either. See, it tries to load it, but no. So we may be stuck with MS-DOS 2.1, which is built into ROM. I'm not sure yet. I certainly haven't got it to boot an operating system, but at least we have got it loading some software up. Anyway, that's not really what this this particular video is about. We'll just switch that off for now. Get it all shut down. What I would like to try and do today, we'll get this disconnected, and we'll push that out of the way, is have a look at the battery pack here, and see if we can actually get this thing loaded, actually charging its original battery pack and actually running off a well, not initially the original transformer, but a correct transformer for it, and then we'll look at repairing the original transformer. But I thought we'd do in this video is see what we can do with this battery pack. And what I've got here, I've salvaged these out of an old drill battery, which basically sustained some physical damage. Yeah, it fell off my ladder. and smashed. But there was nothing, I mean, it weren't in the best of orders, it weren't exactly a brand new battery or anything, but it did still work. So I managed to salvage 4 correct cells, and these are identical to the cells using this, the NiCad cells, 1.2 volts each. I think they're like 1300 milliamp hour or something like that. Not a huge amount by modern standards, but they'll do the job. Like I said, they're not in brilliant condition, but they do at least work. I have tested them all, and they all are showing about between 1 and 1.2 volts, so they're absolutely fine. So what we will do is we'll get this battery pack apart, we'll have a look how it's built, and then we'll have a look at replacing the cells out of it with these salvaged ones. I mean, I could buy a new set of cells for it, but they're quite expensive, to be honest. They'll probably set me back, what, about £10 plus postage for 4 of these NiCad cells, so I might as well do the cheapo and rebuild them. I'm not really relying on the battery pack anyway. It is more for just for curiosity if I can get it running the original in the original way. Hey, look at that! Actually, this is a replacement pack. This isn't the original from the. I've just noticed this isn't the original from the laptop. If we look here, you see that we've got a date on it, the 8th of the 5th, 92. So this was replaced in 1992, and the computer was built in 1987. So let's see what we can find we can get into this pack with. Why do all your knives disappear when that's what you need? Some screwdrivers and some clippers there. We'll get them out. I actually have a nice sharp blade in here, and what's that? There we go. Nice Stanley blade there. That should do. We'll have to be careful, but it'd be nice to reuse this this wrapping actually, and perhaps just put some tape around it. Let's get in here anyway. We'll slit it open right along. I can already see some crust coming out of that as soon as I cut into it there. There we go. So we don't have to really worry about shorting anything out, because as we've already checked, there's absolutely nothing left in this battery. But we don't want to really pierce the cells or anything, because that would just be messy. So I would try. I could just tear this covering off, but I'm trying to take it off in a way that if I want, I can reuse it. I can put it back on the replacement rebuilt batteries and make them look a bit more original. Or I can just wrap it in tape. I mean, that's the other option. If I can't, I'll just wrap the new pack in insulation tape to make it look neat and tidy. There we go, we're in. Ugh, and those are seriously crusty. When you have a look in there, you can see the batteries are pretty well shot. Let's get, dear me, look at that. Yuck. So this is incredible. There's no form of sensing or anything on this whatsoever, and it is exactly as I thought. We've got 2 wires. They've just paralleled up the wires for some reason, and I don't really know why, because you're not going to be pulling a ridiculous amount of current. You're not going to overheat one of them wires. But yeah, that's all they've done. They've just paralleled them all up, because there's not even anything to sense temperature or anything in there. So this should be fairly easy. All we need to do is desolder these 2 contacts, then make these up in a series arrangement, solder those wires back onto the end of it, and rewrap it in this. Actually, I do want to reuse that because it's got the Toshiba branding and everything on it. It will make it look like just that little bit more original. So I think we'll cut some of this tape away and we can desolder these connectors. Yeah, this is horrible. There we go, we can get to that one. We can get to that one. I've got my soldering iron already preheated up. I'll just find a bit of solder so I can wet it slightly for ender clean. There we go, that's the first one's off. Should be able to do the same on this side. Add a little bit more solder to that, get it to flow. There we go, that's one off. You don't want to get it too hot because you are working on a battery here, but these are designed to be soldered to. There we go, that's two off. And that can go straight for, I mean, I won't throw that straight in the bin. Next time I'm down at Tesco's or B&Q, that can go in one of their battery recycling bins. I'll just put that out of harm's way for now though. Right, and let's have a look at configuring these salvage cells up. So basically what we need to do, we'll flatten down these tabs. Because we will have to reuse the tabs to some extent, because these are what we're going to have to solder to. That's that one. A bit of one on that side there. From the top of the battery to fold that flat. We can solder onto the end of there though, that's fine. That one's okay. That one's okay. And again, that one, we'll probably just cut that off there and we can use that to solder the new bit onto. So some older snips. I'm not using my nice ones for cutting this. Cut that there, get rid of that. Right, so we've got a good set of cells there, so all we really need to do is arrange them in order. So if that's negative, that's positive. The next one needs to go the opposite way round, so actually, we'll have to bend that. We'll have that one as an end one, actually. We'll use this one here. And this is, it's a bit of faffing around really, just to get everything to line up right. So if that's the positive, that goes to there. That one I need to bend over like that, and them two will go together like that. And then we need one with a decent negative on it. Oh, we'll have to do a bit of fanning around there. We'll have to solder a little bridge wire between them two. We'll keep them all nice and square together. Like that. Right, last one. Again, we'll have to bend that over so it is in the right place and push that to there. That should work. then we should be able to solder all them together, and that should give us our basically our negative on that side there and our positive on that side there. That should work really nicely. So what I need to do is I just need to hold them in position for now, and we'll just use a bit of sellotape. That is basically what was used in the original. I don't see it's going to be a problem. Oops. The tricky bit is now turning this over and keeping all the batteries exactly where I want them. Then we can tape the other side. There we go. And get another bit of tape on that side. I'll just slightly rearrange a couple of them batteries so the contacts are going to solder together better, like that. Put that down. Wrap that around like that. Right, there we go, because that is basically what we had in the old one. Now all we need to do is solder these, basically solder that to there, solder that to there, and then we'll do the same on the other side, and we'll reattach the lead out wires to it, and then we can test it. There should be a voltage in it. I mean, it won't be the full voltage. They are slightly discharged, these cells, but they will charge. Like I said, there is nothing actually wrong with the cells. It was the fact that the battery took a dive off the top of my ladder that killed it. So we'll just do a bit of solder, like that. That's them two soldered together. Just bear in mind that was my other laptop that I did my disk image with, just shutting down on there. There we go. Just let that cool for a second before we flip it over and basically do the same thing on the other side. We are probably going to have to need a little bit of metal to bridge them two contacts on the other side, but that should be easy enough. Yep, that's okay on that side. So all we need to do basically is bridge them two together. Then we can add our lead out wires to it. So we need a little bit of either a little bit of thin metal, a little bit of thin tin or something. In fact, a little bit of thin tin would be ideal. Have I got any old tin cans kicking about? I don't think I have got any old tin cans up here. What can we use? What can we use? A bit of shielding would be ideal, actually. A bit of old RF shielding or something like that would probably do the job. Oops. Ah, I wonder. It's probably got a coating on that that'd stop it working. I just had an old floppy disk there that was no good. I was wondering whether I could use a bit of shutter off that to do it. It might work, actually. I mean, the disk's no use, so let's see if this disc material will take solder. I'm not sure. Whether it's got a coating on it or whether it's a stainless steel or what, but we can give it a quick try. I think that'd be a definite no. Well, that's not going to take, that won't take solder, unfortunately. Well, actually, yes it bloody does. Yes, it does. I didn't think that had soldered on there, but yeah, if you look, that was not coming off there. So yes, we can use a piece of this, we can use a little piece of this. this old floppy disk. This disk shutter. That's actually a really useful thing to know if I need to make battery contacts in the future. And I want some flat, easy to obtain metal, because we've all got loads of floppy disks which are basically no use anymore. They've got bit rot on them, but you don't want to throw them away. I think we just found a use for them. So there, we broke a bit of that off, and that'll be just right there to let me zoom you in a bit so you can see what I'm doing. So what I'm going to do is I'm going to add a little bit of solder there, and then we will put that on and we'll solder that across them two contacts, and that should give us, and then obviously that's our positive, that's our negative. Then we will reattach the lead out wires, which will fit exactly like they did on the original. We'll reassemble it in the plastic and we'll give it a try. Right, so we need to solder them two in place, don't we? So where's my solder? That's no use, that one. There we go. Let's tin them up first. Like that. That took the tinning really well, that one didn't quite so much. We have to use a bit of flux. Let's take our bit of disk drive metal, which should work quite nicely. Apply the heat on top and see if we can get it to melt that solder down, and then we'll add a little bit more solder to the top of that. Probably do with an iron that's a little bit hotter than this, to be fair. It is struggling a little bit with the first thing actually I've encountered this iron seems to have struggled with. We've got it down there. We'll solder this side and then we can solder that and add a little bit more. It definitely is struggling a little bit, this. I'll try perhaps a little bit of flux on it. Let's see if we can get a little bit more flow action with a bit of flux. There we go. Add a bit of flux to it. I'll just crank the iron up ever so slightly. Let's see if that will help. Okay, here we go. Doesn't want to stick for some reason. No, look. Let's try something else. Let's try a piece of good old-fashioned copper wire. It should do the job, to be honest. I mean, the solder was adhering to that when I just tried a bit. Perhaps if I had a much hotter iron, we may be able to get it to work, but that iron's struggling a little bit. I think if we've got a couple of pieces of reasonably thick wire and put them across there and solder them across, that should do the job. I'm just trying to think what I've got that's reasonably thick that we can do that with. I should have something kicking about somewhere. Let's have a look at this. Ah, that's perfect. We've got a bit of earth wire here, we can solder that across there, that'll work. In fact, if I take all the insulation off it, and twist it together, and there we go, fold it in half. That can take quite a lot of current. We can solder that there across there, like that, and that should do the job. Let's give it a go. There we go, that side's soldered. That was much easier. We should be able to do the same on this side. In fact, we move them wires over where we was trying to solder that on before, because we've already got a nice tinned area there. We can always cut the excess off when we've finished. There we go. And we can solder them in place, and then we can just trim off the excess that we don't need. That's that one done. There we go. Just let them cool down a little bit. We have, well, the batteries aren't even hot. The batteries are absolutely fine. I'll zoom you out so you're not just seeing my arms. There we go. We can snip off that little excess bits of wire. Like that. And there we are. So we're soldered on that side there. Soldered on that side there, so we should have, well, if these batteries were fully charged, we'd have 4.8 volts across there. Let's see what we have got across there, just to make sure that this thing is going to actually work. Yeah, we're getting what, about 3.5 volts there. So yeah, they are a bit undercharged, but they will recharge. They should be absolutely fine. They're not like the other, the old pack, which was basically a dead short. So we can, we'll tin up them two connections there, and then we will add the lead out wires, and we'll fix it back into the package and see whether we can actually get it to do anything. So let's tin that up. We'll tin this one up. Like that. Take them two wires. Try and hold them together close so I can solder them both at once, you see. So we hold them like that. Hopefully we should get the solder to, there we go. So that's them two back on, and we've just got the two positives to go on this side. And then we can have a look at reassembling the outer casing. We'll just have to use a little bit of sellotape for that, I think. I mean, it won't be as perfect as the original, but at least it'll look fairly unmolested if anyone looks inside the computer. There we go. Just hold them while it cools off. Right, they're connected. So I think what we need is a little bit of sellotape over there and over there, because that's how it was done on the original. Why do you always lose the end on sellotape and it takes horrible to find again? So we'll put a bit of tape over there like that. Like I said, that's how it was done on the original one, and we'll do the same there. Like that. Put a final little bit there just to secure that in place. I'm sure it's not as neat as the original, but like I said, we'll put that there we go. We'll put the original covering back over it anyway, just to make it look that bit more authentic, if it will fit. We might have to squeeze it in a bit, because obviously my resoldered connections aren't going to be anywhere near as good as the originals, and this was a thing that would be heat shrunk on. It would be nice if if we can get it to fit over. So just make the batteries look that little bit more authentic. It doesn't look perfect, but it's better than not having any original covering on it at all, I suppose. Just have to get a bit of tape on the bottom there just to hold it in. So unfortunately, if you use brand new batteries, obviously it would be a lot easier this, but I'm using what I've got that's not cost me anything. There we go. There we are. So it's not perfect, but it's better than nothing. That, I believe, snaps. Hopefully, it'll go back in its just squeezes it out a little bit, but I don't think that'll matter. Let's try and get the yeah, that works. So it's kind of pushing the plastic out a little bit, but it's not to a horrendous extent, so I think we can get away with that. Let's push that down, put the screw back in. There we are. Now it's back in its case, you really can't tell. So, is it going to work? That is the question. Let's, are you all zoomed out here? There we go. Let's get the laptop back in and let's try and see if we can actually get it to work off a charger with the battery pack installed. Let us see. Because if this doesn't work, I might actually go and bite the bullet and buy some brand new cells, but if this does work, then all the better, because it's saved me well, the battery, I mean the pack actually fits physically in position okay, even though it, like I say, it's a little bit on the bulgy side. I'll unplug my temporary power supply, my old 5 volt iPad supply, and we'll connect up this 9 volt DC 2 amp supply and plug that in, switch on. Let's switch on. I don't know if you saw that then, but the power light did actually flick on for a second then. Switch off again. Switch on. If you, like I say, you see it flicked. You know, it wasn't doing that earlier even with the old pack on it. But it's not actually powering up completely. Try it again. Interesting. Let's try. Just make sure we are getting a decent voltage out of the end of the pack there. If we switch it on with the battery disconnected, you don't get anything at all happening. It could be that the battery is just a tiny little bit on the flat side. What I could do, I've got an iMax B6 charger. Now you see, it's showing it's showing 3.81 volts there, which you'd expect to be enough. I wonder if it can't actually power the laptop up unless it's got a full charge in the battery. That could be a distinct possibility. Try putting it back in. In fact, I wonder what I'll do. I've got it connected back up into the laptop. I've got the laptop switched on. I'm just going to probe and see what voltages we've actually got. Is the battery actually charging? It's showing 4.1 volts there. If you can see, that's with me basically on the plus and the negative coming out of the motherboard into the battery. Now if you remember last time when we was trying this, we were getting all kinds of erratic voltages. When we had the battery connected, we were getting basically nothing at all. I wonder if it's worth for a while just monitoring that and see if that just keeps going up a little bit. Could that be me? I've just lost contact. Hang on. Yeah, that was me just losing contact. So if that looks like it's climbing, doesn't it? So I wonder whether if I leave it a few hours, whether the battery's actually going to charge up and then it's actually going to allow the computer to run. Because that's certainly a lot better than was. Yeah, because that's going up to 413 there, and it started at what 411 when we, and then you see it's moving up again 414. So it's as though the battery voltage is very steadily climbing. So I think this is possibly actually working, and all the issue we've got at the moment is basically these batteries are low on charge. I mean, I knew that they weren't in a good charge state when I started. I did test them. I knew that the batteries were actually physically alright, but they were a bit low on charge. It does actually look like, amazingly, they may charge up in this. It may actually allow them to charge, and then the computer could work. It could literally be that it won't run with batteries which are completely flat. This video seems to have dragged on a little bit. I was only planning to do like 20 to perhaps 30 minutes, and we're already up to 40 minutes. So I think I'm probably going to leave it there for now, and in the next part we'll see whether this battery has actually recovered and it's going to power the laptop. If not, I think I'll bite the bullet and buy a new battery for it. Or I'm kind of tempted. We've got this little metal plate here on the back. Could I take that off and add a 5-volt DC jack on the back and we power the laptop like that? I was saying though, we do seem to be getting making some progress on it at least. Like I said, you've seen some software run on it. Okay, we've not been able to boot a boot disk on it yet, but at least we've proved that the disk drive's basically working. And like I said, DigDug run surprisingly well on it. And yeah, I'm wondering what to do. I'm wondering what to do now, power supply wise. It all depends on whether this battery. If this battery charges and we start getting it to work, then I probably just leave it like that. Like I said, if it doesn't, do I go to the expense of rebuilding this battery pack, or do I just provide an external alternative power source for it? Comments in the description, and we'll take it from there. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on the project. So, thanks for watching and goodbye.